Welcome to a Stuart 7A model steam plant. In this episode, part 26, I'm going to show how to make a brass cap for the chimney. And the first thing I need is a piece of brass, but unfortunately the only piece of brass I have of the correct diameter is very long. Cutting this piece of brass took ages. I even had to put a weight on the bandsaw. And while the bandsaw was doing its stuff, I went into the outer part of the workshop to start the clean-up procedure on the copper tube which will become the chimney. I started the job off on the polishing spindle, as you can see, and I finished the job on the bench using some Bandsaw wadding. This stuff is really good. It's been around for a long time and it's great for polishing metal. Meanwhile, back at the bandsaw, well, it's nearly halfway through now. Note to self, I think it's time to change the blade. Back to the chimney. After the Bandsaw wadding, it's time for the cotton cloth. As I'm still waiting for the bandsaw blade to get all the way through the piece of brass, I thought I'd have a look at this. This is a spare inlet to the boiler for a second check valve, which is currently blocked off with a blanking plug. I also decided, while I'm still waiting for this piece of brass to cut, that it would be a good idea to remove the water tank. I need to fit an extra water outlet to this for the steam pump. I was speaking to the owner of the steam plant last week, and he was asking about the possibility of putting a valve on the water outlet to the boiler. So thinking about it, here's the ideal opportunity. Instead of a check valve, just screw in an ordinary steam valve. I tried this and it was no problem. I took the valve in and out a couple of times to find the correct thickness of washer, so that the valve's outlet, which is now the water inlet to the boiler, ended up in the right position for the pipe. In the end though, I abandoned this idea, because the valve is too close to a part of the boiler that gets very hot when it's in steam. Besides, the best plan is a water bypass valve. That way when the plant is in steam, the pump can be running, and with the bypass valve open, the water will return to the tank, close the valve, and the water goes in the boiler. I'm trying to contain my excitement at this point, because at last the piece of brass was cut to the correct size to fit in the chuck. And the first thing to do, as always, is face across the front to clean it up. This part of the sequence is running in real time. Later on I will be speeding it up though. Sometimes I really miss my old Smart & Brown lathe, because it was much larger than the small Boxford that I used for making the videos. Why did I sell it to my friend and leave it back in West Yorkshire instead of bringing it with me? Well, the answer is quite simple. I do not know a lot of beginners to this hobby who have a really big industrial tool room lathe in their workshop. And now, for the umpteenth time, I'm going to make a statement. The original idea of making these videos was to give something back and help beginners to the fascinating hobby of model engineering in a home workshop. That's all, so everything is kept simple. I do not use any specialist tools whatsoever. When I checked the YouTube public comments this morning, as per usual, an expert commented. My first question is obviously, why is an expert, if he is an expert, watching a video specifically designed for beginners? He was telling me that I should use an angle plate and a face plate to do some job or another that he'd seen on one of my videos. I replied to this question because it really annoys me that people presume that beginners have face plates and Keats angle plates, and in normal circumstances have enough free time to mess about with these pieces of equipment. I just get on with the job in the simplest manner and then show beginners how to do it. It works for me, so it should work for beginners. I replied to this expert, but it took some time to do that, so I think in future I'm just going to delete comments like this. Anyone thinking about writing in, don't forget, before the comment goes on the channel, however good or bad it is, it comes to me first for approval. I never get upset by these comments. There's much more to life than getting upset about stupid comments from so-called experts and or fools. And while I've been telling you this, I'm trying to drill a hole through the middle of the brass. I find the best way to do this after centre drilling the work is to go through with a small drill first, then go through with a slightly larger drill, and finally drill through with the largest twist drill that you have, providing it's not larger than the tube that's going to go in the hole. As far as I can remember, this drill bit is 1 inch in diameter. If during these sequences you see the lathe slowing down, please don't worry about it. I keep the belts purposely slack, and this reduces the power of the lathe, so if I get a lock-up, it's most unlikely that anything is going to break. Things will move around and it doesn't look good or sound good, but at least it doesn't snap off the tool holder like it used to do on the old Smart & Brown lathe. After drilling the hole about 1.25 inches deep into the piece of brass, here comes the boring bit, literally. This is quite a small boring tool. I was given a boring tool by a man called Dan, and it's really good. But for this simple brass boring job, I thought I would use the smaller tool. I'm only taking fine cuts because the tool is small and it will bend. If I take too deep a cut, it digs in and makes a really horrible sound. The squeaking noise that you just heard is when the tool gets to the end of the drilled hole. I think it's time to check that I'm not boring this hole too big. No, it's okay so far. Time to check it with my digital caliper. And now I'm getting close to the finished size, so I have to be very careful. Fine cuts are definitely the order of the day. And now the polished copper tube, which is the main chimney, fits into the brass cap perfectly. I've changed the lathe tool for a round nose tool. This is completely freehand. I'm shaping the lump of brass into the shape that you would normally find at the top of a chimney. Pretty much like a locomotive chimney, not a mill chimney. When this is finished, it should look quite good. The only rule here is to not take too deep a cut, because you do not want the tool to chatter. Now it's time to part off the piece of brass, being very careful to make sure that I leave a ridge inside. Normally I wouldn't have to do it this way, but I've no choice, because the chimney tube is too large a diameter to go down the lathe spindle. Ordinarily at this point I would put the chimney tube in the chuck, press on the brass cap and finish the turning in situ, but unfortunately I can't do that, so this is an alternative way of making a chimney top cap if you have a small lathe. A final clean-up of the inside edge of the top cap completes the job. Health and safety, please note that the only thing inside the top cap is the piece of emery cloth and not my fingers. That's it, this part of the job is done. All I then had to do was press the cap onto the chimney. Here I'm checking that there are no sharp edges inside it. And yes, that's fine, the job is now complete. And that's the end of the episode. I'd just like to say, stay safe, stay well, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.